Okay, good morning, everyone. This is Victor Murphy. I'm with the National Weather Service Southern Region headquarters here in Fort Worth. I'm the Climate Service Program Manager for our region. I want to go and get started on this call. I'm showing straight up 11 o'clock here. I want to thank you for joining in. We've got about 50 or so attendees so far, I think over 100 registered. So hopefully this will be beneficial for you. Needless to say, the Southern Plains drought, which right now encompasses, parts of 5 different states: Colorado, Kansas, Oklahoma, Texas, and New Mexico, since about the first week of October, so October 10th, has been quite significant. And we've got the pleasure of having Professor John Nielsen-Gammon here as presenter. John's a state climatologist for the state of Texas. And I would ask everyone real quick, I'm sorry, to please mute your phones. You can do so by hitting *6.
Victor, stop talking. Let that person hear themselves.
Yeah. Okay.
There you go.
Anyone in advance, like I said, please mute your phones or hit *6. We will have plenty of time for Q&A afterwards. On the webinar, if you want to ask a question, you just go ahead and either raise your hand or hit the chat button there and type any questions you may have. So we intend to have these things monthly. The next one will probably be about middle of April or so. We'll obviously give everyone plenty of heads up or lead time on that. I want to thank Doug Cluck, the NOAA Regional Climate Services Director, for putting this together or participating in this, as well as Elizabeth Waite of the NIDIS Program Office in National Integrated Drought Information System. And so, Doug, is there anything you want to add before we start the call?
I just want to say that, first of all, thank you, Victor, for hosting this. I know this is this is the first time Victor's sort of played around with this webinar, so bear with us a little bit. I'll sort of apologize for him. One of the things that's a little odd about this phone call is that we cannot force mute you. So all the shuffling of papers and sneezing and talking to your neighbors, we're going to hear that, unfortunately, unless you mute, not hold. Don't put us on hold, unless you mute your phone. And so please mute your phone so we don't have any disruptions. Thank you.
Elizabeth, is there anything you want to add on behalf of NIDIS?
I just want to say thanks to you all for organizing this. I think it's a great collaborative effort, and I look forward to working with you going forward. Thanks a lot.
Thanks, Elizabeth. Go ahead, John.
All right. Thank you, Victor. So I am John Nielsen-Gammon, the Texas State Climatologist, and I'll be leading this month's webinar. I'll start with an overview of the current status of the drought, present some overview of the meteorological conditions and indicators that describe the area and severity of the drought. And I'll focus on 3 of the impacts that are particularly prominent right now, and then look at what's in store over the next day to season. This shows why we're having this call. The Southern Plains drought is not unique. It's not the only drought across the United States, but it is the first emergence of D4, which is exceptional drought. Drought extends all the way across the Four Corners region into California, but the impacts in the Southern Plains tend to be quite a bit different from the impacts in the southwestern U.S., so we're focusing specifically on the Southern Plains in these webinars. This is the change in the U.S. Drought Monitor category since last summer, and it shows that the drought really is a emerging phenomenon. We've gone from no unusual dryness whatsoever to D4 exceptional drought in parts of Oklahoma and Texas, and the entire Southern Plains drought region is really something that developed fairly recently. This animation shows the evolution of the drought monitor since December. Basically what's happened is that we've had very little precipitation in the region for the past several months. That was not entirely unanticipated. Of course, you can never predict something this severe several months in advance, but we did know going in that it was potentially going to be a challenging cold season for the Southern Plains and the Southern United States, given that we had a La Nina developing in the tropical Pacific Ocean, as indicated by below normal temperatures across most of the central and eastern tropical Pacific. That La Nina has peaked already and is, according to Climate Prediction Center, basically on its way out. We should be back to neutral conditions in the tropical Pacific by sometime this spring. The outlooks for the wintertime, based upon La Nina, tended to show above normal temperatures and below normal precipitation probabilities across the southern United States, which is consistent with what normally happens during a La Nina. But the dryness is never uniformly distributed across the southern United States. There are going to be particular pockets which are especially unlucky. And in this particular year, it was the Southern Plains that was unlucky. So now looking at the meteorological conditions, the region had decent amounts of rainfall over the summertime, especially across Oklahoma, Texas, and New Mexico. Colorado was on the dry side, as were parts of Kansas and parts of northern Oklahoma in the Panhandle. The situation seriously changed after the first week of October, though, and the precipitation since November has been ridiculously low. The dark red areas are locations where there's been less than 1/10 of an inch of rainfall over the past 5-month period. And for probably all of those locations, this is perhaps the record longest period of time with less than 1/10 of an inch of rainfall, and even 1/4 of an inch of rainfall is an unusually low number, despite the fact that wintertime is climatologically the driest time of the year for the region. The number of days with less than 1/4 of an inch is now stretched up to more than 5 months worth, and conceivably could hit the 6-month mark depending upon how the weather plays out. I want to go back to this map and emphasize that the consequences of soil moisture have been a bit unusual because we had plenty of moisture in the soil profile, but the very top part of the soil is dry, as I'll show you in a moment. The precipitation totals over the entire region, as indicated by the SPI, the Standardized Precipitation Index, for the past 4 months, shows lots of reds and dark reds and browns. Each one of those dots represents a station that's been reporting regularly over the long haul. And anything that's dark red and brown is likely to represent record dry conditions for this time of year. Probabilities of anything below -2 essentially corresponds to extreme or exceptional drought conditions based on that particular time scale. Another version of a similar product that is produced by North Carolina State University with some technology that we helped develop shows, based on radar estimated precipitation integrated with gauges, the spatial extent of the dryness. And here, this particular product is based on the past 4 months, but includes a little bit of influence for precipitation for more than 4 months prior, which is the only reason that the western part of the Southern Plains is looking better than the eastern part. It's because the western part received a lot more rainfall during the summertime, so it effectively had water in the soil bank that has helped alleviate the onset of drought conditions there, but still hasn't been enough to overcome the record dryness that's been experienced since October. Temperatures have been relatively close to normal. Maximum temperatures over the wintertime were slightly above normal across the region, whereas the minimum temperatures were generally below normal, reflective of the dry conditions. The lack of cloud cover makes for bigger swings in daytime temperatures. We also had some significant cold snaps come through the region. The soil moisture, we have good observations from Oklahoma mesonet in particular. The top diagram is the average amount of plant available water in the top 4 inches of soil. That's relevant for any newly planted or young crops. And you can see totals of less than 1/10 of an inch of water available across the entirety of the Oklahoma Panhandle. You go a bit farther down, you find percent of available water is still quite low over the top 16 inches, but not as dramatically low as the top 4 inches. Now, most national soil maps, such as the one that I'm showing now, are based on soil moisture over a fairly deep layer of the soil. So if you compare this to the Oklahoma top 16-inch map over on the right, you see it reflects the pattern fairly well, but it's not really capturing the extreme intensity of the dryness of the very top part of the soil, which is relevant to young crops. And the last indicator I want to show, this is the evaporative demand drought index, which reflects basically the extent to which the atmosphere is drawing water out of the soil at an unusual rate through evaporation or transpiration. And that highlights that we have emerging drought conditions in Colorado and Kansas because of the unusual temperatures, clear skies, winds, etc. For many parts of the region, snowpack is also relevant in the sense that the snowpack supplies water to the Arkansas River and other important river basins in the region, which to some extent is used for irrigation and for water supply. And this has been an unusually dry year for snow. You find that the basins in southern Colorado and New Mexico are all showing below normal or actually below median snow water equivalent, with some basins down well below 25% of normal. The Amarillo snow water equivalent is shown here. Sorry, the Arkansas River snow water equivalent is shown here. Normal is the yellow curve. Various other years are highlighted. The thick black curve is the current year, going up through the middle of March. And if there's no additional snow over the next 7 days, that basin will be in record low snow water equivalent amounts for this time of year. And if there's not additional snow water equivalent produced over the next month or so, the peak snow water equivalent will be a record low also. Okay, turning to impacts. Probably the biggest impact that's been ongoing is to the winter wheat crop. Because of the drought conditions, we have many counties in Kansas being listed in drought emergency conditions. That's a combination of the impacts I'm going to talk about. The winter wheat for Kansas. This shows the past 9 years of status of winter wheat at the middle of March. And as you see, for the year 2018 over on the right, there's over 15% of the crop is rated as very poor, which is higher than any time this decade. Over 50% is listed as poor to very poor, which is also higher than any previous crop this past decade, including the drought of 2011. Situation in Texas is even worse, with about almost a third of the crop being rated as very poor. Again, that's a high value for this past decade. And in Oklahoma, we see almost about quarter very poor, and 2/3 is poor to very poor, which by far is the worst conditions for this time of year over the decade. This is what the conditions look like in some of the hardest hit areas. This is a photograph from near Knowles, Oklahoma, showing that basically the planted wheat has been reduced to stubble at this point, a total loss for that particular field. Conditions vary across the southern plains, but this is typical of the hardest hit areas. And a broader view of this shows how a good year for winter wheat shows widespread areas of western Oklahoma in green, high levels of greenness, according to satellite imagery, whereas there's essentially no green areas in the present year. I did an analysis of how the precipitation through this time of year has affected the winter wheat crop in the northern Texas panhandle by comparing the precipitation in fall and winter to the yield compared to averages, taking into account the improved yields over time due to grain varieties and farming techniques. What we see here are two sets of dots, one for a wet fall, and which is what we had through the beginning of October, and one for a dry fall. And you can see there's a strong dependence in both cases on the amount of precipitation from November through the present time. Zero precipitation, which is basically what Amarillo has received, combined with the wet fall, would predict about a yield of 60% of the long-term average and a yield of less than half of what you would typically get during a good year.
Say, I'm going to stop you right there for a minute, John. Hey, if you're not on mute, put yourself on mute, please. We're hearing some background noises, unless John's dancing around his office, which I don't think he is right now. But thank you. Go ahead, John. Sorry.
Well, if I were dancing, it probably would make a lot of noise, given my dancing abilities. But anyhow, the fact that we had a wet fall, you can see, makes less and less of a difference as things dry out in the wintertime. It's probably only managed to produce an extra forecast of an extra 10% of yield compared to what would have happened in a dry fall. Next question is, looking forward, what happens if we get decent amounts of rain in the next couple months? And in this plot, you see, in general, the higher the amount of rainfall in the spring, the better the yield. But if we focus only on the maroon symbols, which represent the dry winter, you can see that there's almost no correlation. You're basically guaranteed to have a yield that's below the long-term median, no matter how much rain occurs in the springtime. So even if the drought ends tomorrow, which it won't, the winter wheat impacts will from the drought will continue through time of harvest for those acres that actually are worth harvesting. For livestock, of course, the lack of winter wheat means a lack of ability for cattle to forage on winter wheat. Also, natural vegetation is suffering, and stock tanks are quite a bit lower than normal. This is an image from western Oklahoma showing a very low stock tank, and a solar powered pump that's supplying water to the stock tank is certainly not able to keep up with the dry conditions. Third major impact is fire danger. A fire update from the U.S. Forest Service reports that because of the wet year that we had leading up to this winter and spring, and because of developing drought and the delayed green up due to the lack of water, the fuels are quite abundant in the region, 130 to 150% of normal, and that combined with the frequent, critical, and occasional extreme fire weather conditions is expected to lead to extreme to unprecedented fire growth and intensity. That assessment covers all of the drought region in the southern plains, extending all the way down to the Rio Grande. Again, a picture from Monica in Oklahoma shows the fuels available. This is extremely dry. You also see some branches lying on the ground, which is a reflection in part of the severe ice storm that also occurred in southwestern Kansas and northwestern Oklahoma, which leads to a lot of debris on the ground from tree limbs and shrubs. So far this year, the fires have not been markedly above normal. The number of fires is presently fourth highest over the past decade. Acreage burned is sixth highest over the past decade, but that all may change. We had a major fire a couple of weeks ago, the State Line Fire, which burned close to 30,000 acres. And we're in the middle of a potential fire outbreak right now. Satellite image from yesterday shows several major plumes from fires that are visible in the satellite imagery. The two arrows in western Oklahoma are actually pointing to the same plume. Fire developed so quickly and was so intense and the wind strong enough that the plume made it to the Kansas border by late afternoon. And there are a lot of other fire plumes that are too small to really deserve being identified here. The orange arrow in the lower left in New Mexico is showing not a smoke plume, but a plume of dust from White Sands, New Mexico, which reminds me to note that the dry conditions and strong winds also lead to serious wind erosion, and that's a potential concern for not just the winter wheat to have soil loss and be battered by dust, but also concern for preparation for fields for spring planting. The fire outlook for today, by the way, is critical in the entire five-state region affected by drought, with the exception of central to northwest Kansas, which is spared the extreme fire danger because of lack of strong winds in the forecast. One impact I haven't mentioned is water supply, and that's because, again, we had a very wet summer, and indeed the past 3 years have been wet across the region. So except for short-term supplies like stock tanks, conditions are very good. This is the Lake Meredith, which is a lake north of Oklahoma, which is fed in part by runoff from the Sangre de Cristo Mountains, but also from rainfall upstream. And it's now sitting at close to 40% of normal, and it hasn't been that high for the past 15 years. Okay, now turning to the outlook, short-range weather forecast for the next week all the way out to summertime. The precipitation forecast from National Centers for Environmental Prediction have a mixture of good news and bad news across the region. Zero precipitation forecasted for extreme southeast Colorado, eastern New Mexico, and western parts of the Oklahoma and Texas panhandles. Meanwhile, central and northwestern Kansas is forecasted to receive from a half an inch up to as much as 1.5 inches of rainfall, which would, as earlier mentioned, not do that much good to the wheat crop in the core drought region, but would at least improve conditions for livestock and improve conditions for spring planting. The rainfall is primarily forecasted to occur during Sunday and Monday, Here's a sequence of weather map forecasts which show an intensifying low pressure system across the region. This is your typical good news, bad news scenario because a rapidly developing low also tends to lead to extreme fire danger in locations south of that low. So we are looking at potentially busy fire day, not just today, but also on Sunday across New Mexico, Oklahoma Panhandle, and the Texas Panhandle. Over the following week, the outlook is basically a flip of the coin. Near no particular high chance of above normal or below normal precipitation, which is actually a good thing since we've been having below normal precipitation week after week across the region. Likewise, going forward, there's not a strong indication of dry conditions. Equal chances of above, near normal, or below normal across most of the southern plain region, but New Mexico and far western Texas do have an enhanced probability of dry conditions, both for the month of April and for April through June, according to the Climate Prediction Center outlook that was released yesterday. The temperature outlook, unfortunately, is not helpful. There's an extremely high probability of above normal temperatures for the rest of the spring and early part of the summer across the entire affected region, which means that any precipitation that does fall over the next 3 months is likely to evaporate relatively quickly, at the same time that crops and forage are requiring more water because of the high temperatures. So that means if and when the rains do return, drought recovery, both in terms of recovery of forage and foliage and recovery of the soil moisture profile, will proceed slower than would be expected, even with a normal amount of rainfall. And taking all of that into account, the latest U.S. drought outlook for the next 3 months, again issued yesterday, shows that the drought is indeed expected to persist across that region in the absence of any indication of above normal precipitation and given the strong signal for above normal temperatures being forecasted. Those are primarily due to the continuing La Nina impacts, which tend to persist for an additional month or two, even as La Nina weakens. In the summertime, we'll be back to neutral conditions in the tropical Pacific, and there's not much of a seasonal forecasting signal for late summer and fall at present. So we really can only look forward the next few months as far as what the outlooks are telling us. Given ongoing drought and the expectation that drought will persist, here are some of the impacts that we're likely to see emerging over the next couple of months. We should see delayed green up of foliage because of the dry conditions. Dormancy will persist. Wind erosion, as I mentioned, will be an ongoing problem as the climatologically windiest time of year is the spring across the region, so that's an issue. Delayed planting because of the lack of topsoil moisture, except in irrigated areas, although even there, irrigation use will be higher than normal, and in many areas, irrigation is only a supplement to the natural rainfall and can't make up for the complete absence of precipitation that we've seen so far. And the increased fire activity is not just a long-term forecast. We're expected to see that today, for example. And lastly, water allotments for snow-fed rivers. Those allotments are in good shape because of how wet conditions were last year, but the usage of water allotments is going to be much higher than normal because of the dry conditions right now and the ongoing lack of stream flow. So that's the end of my formal presentation. I'll now turn it back over to Victor for question and answer period.
Okay, great. Thank you, John. Excellent presentation. I did get one question in the group about the different categories of the EDDI, the EDDI, Evaporative Drought Demand Index. I sent the questioner was Ben Diamond, and he wanted to know basically to explain the EDDI categories. I sent him a link to the EDDI. John, do you want to perhaps answer that?
Sure, I'll put the map back up.
It's an experimental product from the University of Arizona.
Colorado.
Oh, okay, I'm sorry. University of Colorado.
Anyhow, the color format here is the same as the U.S. Drought Monitor. So the dark maroon, which you see in Kansas, represents conditions that have been only seen climatologically 2% of the time for this time of year. This is based upon satellite data. The period of record is not a full century, so it's not like we've seen this twice in the past century. But it's based on the distribution of this particular index value over the period of record for the satellite data, and fitting that probability distribution, we're seeing conditions which are drier this time of year than anything that's been seen with this product before.
Yeah, and if I may add just a couple more notes, you can look at this particular tool at various time lengths into the future, and you do that based upon what you're trying, what you're trying to find out. I mean, what do you really want to know? Do you want to know more about what we call flash drought sort of a situation, or are you more interested in sort of a longer term? Has there been a heck of a lot of evaporation demand for that particular area over the last, over the last month and into the future, that kind of thing. So I don't know if Mike Hobbins is on, but he certainly could give this a better justification. But I guess the big point is that this is one tool that people who look at drought monitor type people use to better understand the situation in terms of how wet or dry it is. You can see in Montana and sort of north of here how wet it is up there. That's the opposite, obviously. Victor, do you want to open this up to other questions, or? Yeah,
I just put the link on the chat box there for anyone who wants to access the EDDI, and it has the maps and also has some detailed explanation on how it's derived, etc. So yes, any questions from the floor?
Just a couple more logistics things. Just a couple more logistics things before we do that. I'm sorry. This is the first of we'll just say a few or several, however long this drought lasts. Webinars for the southern plains. If that expands, obviously we're going to have to expand the sort of area that we're talking about generally. We hope to do this at least monthly. We may do it more often than that based upon the need. So if you find this useful, we'd love to hear that, and you can write to victor.murphy@noaa.gov and tell him that. What else? Anything else for logistically, Elizabeth or Victor? I guess if you want the PDF of this, we're going to try to make that available. I think for now, if you want the sort of presentation PDF file, if you will, you can either go straight to John or Victor again to get that file. We're trying to record this, but due to some anticipated issues, that may not be as good as Victor. You can explain it. We may not have the sound with it.
Yeah, unfortunately, it's probably involved two different links. One to get the actual webinar, and the slides, and a separate link to the recording. So you can listen to the recording and move the slides accordingly. It should be good to go. Yeah, I would also ask anyone who, speaking of housekeeping duties, if there's anything that you personally say for you or your agency, the organization would like to have covered or touched upon, which we didn't address, feel free to send me an email. And I'll be sure that we include, your impact or your request or your, need for data or information, et cetera, on our next recording. So with that, any questions from the floor there from the group? I think I heard one that was underway.
I have a couple of questions.
Fire away.
Will the Pacific or Atlantic tropical seasons help us?
Okay, for the outlook for the tropics depends upon a couple of things, primarily ENSO conditions as well as tropical Atlantic temperatures. Haven't looked at that tropical temperatures yet, but the outlook for ENSO is presently favors neutral conditions. However, El Nino development is quite sensitive to what sorts of weather develops in the tropical Pacific over the next couple months. So realistically, tropical season storm outlooks have very little predictive value until you get past the spring. So it won't be really until late May and June that we'll have a good idea of what the tropical season looks like.
Although that's a very good question. It's one of those standby answers, I'm afraid.
Yeah, this is Victor. I think, as John mentioned, it looks like right now the most likely scenario for the summertime or the peak of the tropical season would be ENSO neutral, or neither El Nino nor La Nina. So no real good signals there. But the rainfall for most of that area there, at least in the Texas Panhandle, peaks out in the month of June. The April precip is about 1.5 inches for the month of April, which is 50% more than March, and it doubles 277 in 2.5 to 3 inches for May. And so any tropical activity would probably not be, as far as impacting this region, would probably not be until July, August or so, and would more likely be from the Eastern Pacific, some of the remnants of those systems. So any help in the horizon from the tropics probably would not be till June or July anyway, and that's awful late in the game, quite honestly. So so we're gonna need some improvement before then. And the wettest month or months out there, wettest period, is May, June, July, into August, irrespective of any tropical activity.
Victor, I think you had another couple questions or something. Go ahead.
If nobody else has a question, I have one that's very simple. Could you explain or define, you used the terms, John, spring and summer. What months are you defining as spring and what months are you defining as summer?
Spring, I'm regarding as typically March, April, May, and summer would typically be June, July, August. Although the spring weather conditions can persist into early June, and summer lasts until September. But those are the typical seasons for those months for those seasons. Of course, none of my outlooks are precise enough to predict changes in weather regimes down to the week, so it's a fuzzy boundary.
Thank you.
This is Bryce Anderson. Can I chime in, please?
Yeah, go, Bryce.
Yes. Hello. John, a question on the comparison of this drought to back in 2011. Are you concerned that this drought could reach the kind of intensity that we saw back then? And along with that, how concerned are you for possible extensive wheat acreage ripping out because it's so dry, and also about the feed and pasture situation?
Yeah, so comparison with 2011 is a bit scary. The winter wheat was actually helped quite a bit by a wet January. So it was not as bad in 2011 as it might have been. We have been drier to date since 2011 has been across that drought region. So I regard that as basically some of the dominoes that need to fall in order for us to have a drought that's as bad or worse than 2011. Now, spring, as has been mentioned, tends to be wetter than winter, and the outlook is not strongly pointed toward below normal precipitation. So, with a couple of good storm events, we could conceivably be back on track for a decent spring and summer for crops and forage. But on the other hand, you won't have conditions as dry as 2011. If you
if you're not asking a question, can you mute yourself, please? A lot of background noise. Thank you.
Anyhow, you can't have something as dry as 2011. You don't start off dry. So the preconditions are in place to allow that to happen. But the odds of being that dry, well, certainly quite a bit elevated from normal. Most years don't set up this way. Still, it would be unlikely for it to be that dry going forward. So I'm optimistic in that sense, but it's a contingency that we need to be aware of that most years we don't have to worry about. Other question about total loss of wheat crop. Certainly that's going to be location dependent, but we're already seeing winter wheat fields that have been plowed under basically in parts of Oklahoma. So it's not a question of if, but how large an area of wheat is going to be affected by this.
Yeah, and I was wondering if you had any idea if there's going to be a lot, or if now on it's going to kind of be done with from that standpoint, but maybe you don't know right now. I mean, just because it's hard to tell.
Well, I think when it comes down to it, I'll let other people respond after I finish here. For the areas that are really hard to put out, which I regard.
Excuse me for interrupting. Would everybody do *6, please? We've got an awful lot of background noise, and I can't hear John. Thank you.
That worked. Okay. For areas that are basically in D4 and some of the more worse off D3 areas, the wheat crop there is already a loss. And for areas on the margin, other parts of D3 and D2 areas, there's still potential for improvement with timely rains, especially given the outlook. Kansas is well positioned to have a potential recovery due to what's forecasted to occur this weekend. But as far as an overall picture and overall numbers, I can't really give that to you. Anybody else want to add?
Just, John, that it doesn't bode well that we have a fairly strong probability of above normal temperatures from April through June. That alone, that's evaporation. That's during the growing season. Precip is going to be so precip dependent, like every spring. And calling that right now and saying where it's going to fall is tough. I will say, and we all know this as well, that when you have a dry condition going into the summer, let's say going into June, if it's still dry, that's relatively big trouble because, number one, you've missed your key precipitation time of the year, which is spring. And secondarily, you don't have a lot of moisture to work with in the area anymore. So the old saying is dry begets dry, right? And that's what we don't want to see, and that's exactly what happened in 2011. So, it's March now. Next month when we do this call, we'll have a better idea. And of course, the month after that, another one. But in terms of your decision making on various things, that's a tough call. It's just hard. Precipitation is a tough forecast. I will say in the next 2 weeks, it doesn't look good.
Yeah, this is Victor. I would concur with Doug that it doesn't look good the next 2 weeks, at least for the bulk or the brunt of the area. As John mentioned, perhaps parts of southwest Kansas may get some relief. But it's important to mention that if the normal April-May precip comes into play, other than the weed impacts and whatever's current or past impacts on livestock, the total impacts may not be all that significant. For example, so far, December through March, looking at Amarillo, which is sort of the base or the middle point of our area, the total precip for Amarillo December through March is 2.8 inches, or about 0.7 inch per month. The normal precip starts ramping up pretty quickly in April and into May. So the April normal precip is about 1.4 inches per month, which is double what it was the preceding 4 months, per month. And then the May precip average is 2.8 inches, which is basically the entire December through March period altogether. So normal precip going forward, at least during the wet months, which starts in April or May, could quickly alleviate or mitigate a lot of the impacts from this point forward. Of course, but having said that, though, if we do not see the increase in precip in April or May, or it doesn't rain, which should be raining, or when it's the wettest times of year, then the impacts, if anything, will probably just ramp up exponentially. John, here's another question from the group. It's a little bit of a technical question, but it's a good one nonetheless. The Pacific Decadal Oscillation, which is a Pacific Ocean phenomenon, it's been positive now for about 4 years or so. Of course, it was negative back in 2011 and 2012 during the last, major drought. But basically, I guess with the PDO, the Pacific Decadal Oscillation being positive right now, any thoughts at all on the length and severity of this ongoing drought?
Yeah, based on what I've looked at in respect to Texas, and it's probably similar for the other portions of the Southern Plain, the Pacific Decadal Oscillation has its biggest impact on precipitation in the region in the months of December through March. At least it has historically. And it can be neutralized by a La Nina, essentially. Unfortunately, that means that having a positive PDO doesn't really help us until next winter. There's very little relationship between North Pacific weather and the warm season precipitation across this region, as far as I'm aware.
Thank you, John. It's a good question and a sobering answer. Any other questions from the group?
Hey, John, Justin Zerner up here in Wyoming. Just a question. Where are all the starter cattle that typically would be on the wheat pastures going? Are they in feedlots? Have they been shipped to alternative locations? Your thoughts on that?
Hey, and let me just butt in before. Hi, Justin, by the way. Before you answer that, John, you may know the answer, but if you don't, there may be somebody else on this call that does know the answer to that. So please don't hesitate to help answer that question.
Especially after unmuting your phone.
Right. So the question was about starter cattle and what's being done in the Southern Plains generally. If anybody has that information.
This is Clay Pope of the Southern Plains. Some cattle have gone ahead and moved off wheat pasture to the feedlots. A lot of the wheat pasture in central and western, or central Oklahoma and central Kansas and north Texas is hanging on, where we haven't seen a wholesale liquidation of those stockers yet. Placements actually were down a little bit this year on stocker calves, it seemed, because of wheat. A lot of places wheat pasture just didn't get established to begin with. So I think overall your stocker numbers are down, and there have been some calves that have gone ahead and moved on into the feedlots, and anecdotally we're starting to see some of that evidence where that's increasing as this weather continues to hang on.
Good, thank you, Clay.
This is Muthuel Chalaya from CPC. Can people hear me?
Yes. Yep.
Yeah, I just going back to the comparison to the 2011 drought. I was just looking at the CPC historical ENSO values, and obviously you know that that incident there, the La Nina, was much stronger than what we went through right now. So hopefully, I'm looking back at the 2010, 11, 12. So those values of the Nino 3.4 were quite strong all the way from mid-2010 to early 2012. So while we tended to compare to that event, but the current La Nina is not that strong. So hopefully, with expecting transitioning conditions and to neutral, hopefully we won't be affected that long, but let's keep our fingers crossed.
Yep.
Yeah, it's a good point, Muthu. As John mentioned in his presentation, the La Nina, which we're in right now, is one of the probably one of the larger, or not the only, probably the larger reason for the dryness, and that is forecast to abate or to diminish here by the end of springtime. So, as Muthu said, the La Nina of 2010 into in early 2012 was much stronger than this one and more long lasting. So hopefully that will help make this drought, shorter. Right now I think it's sort of in the category of a short-term flash drought. But once again, as you go into the wetter months of the year in this area, May, June, July, etc., then it'll be much more than a flash drought.
Yeah, I just have one more comment for everybody who's still on. If there are questions about impacts and things like that, we'd love to hear your concerns or questions, or even what those impacts are. We can talk for hours, believe me, on the climate setup for all of this on La Nina and El Nino, and there's some really good things to talk about. We can also, but it would be also maybe useful for this audience to hear or understand those impacts of that are underway or current, or things that we should definitely not forget about in April when we do this again. So either send those in an email or feel free to chirp up now and let us know.
Good point, Doug. Any additional questions?
Did a great job, John. Thank you.
Thank you. Yes, it was great.
This is Benjamin Diamond, and I have a question on the Pacific Decadal Oscillation impacts for the growing season.
Okay. Go ahead.
What would be any impact? You were talking a little about the current phase of the Pacific Decadal Oscillation being in a positive phase for the past 5 years. Could you elaborate more on that?
The Pacific Decadal Oscillation is basically the most prominent decadal scale pattern of temperature variation in the North Pacific. A lot of that is tied to El Nino and La Nina. There's also an influence from storm conditions conditions in the wintertime, which affect the ocean temperatures and so forth. As I mentioned, well, the effect of the PDO is not exactly the same as the effect of El Nino, but they're fairly similar. So at least as a first cut, one can think of a positive PDO as having similar sorts of effects as a positive or an El Nino in the southern United States. And that being said, like I mentioned before, it doesn't tend to have much effect on precipitation in this region once we get past the March time frame. So it's not really going to affect, as far as I know, conditions going forward, unless worst case scenario, this drought lasts throughout the year and we're dealing with what's going to happen in the future. But even at that, whether or not we get a El Nino developing next year, that sort of issue is going to be even more important than whether we still have PDO lingering.
I agree.
Does that help, Benjamin?
Yes, thank you.
Any other questions?
Yeah, any other questions from the group? Hopefully I was able to maybe answer your question there, Ben, in the chat a little bit. And I gave you a link also to the additional information on the PDO. But there's many factors at play. I don't think there's one silver bullet that you can point to as far as being, the only cause of this, flash drought or sudden dryness.
If there were, Victor, we'd all be millionaires or billionaires for that matter.
The odd thing is, it's a matter of how you slice and dice information. For example, as John mentioned, this drought began pretty much on a dime, right around on the October 5th through October 10th time frame. In the first week of October, the Dalhart area got a 4-inch rain event, or 4.5 inches of rainfall in the first week of October. So, which is right to start, the traditional water year starts on October 1st. So the water year-to-date rainfall or precipitation for Dalhart from October 1 through today is actually above normal, which is very misleading because if you take away that first week of October, they've had about, I think, a tenth of an inch or so of precip, which of course is probably near record dryness, as John pointed out. So I think for right now it's definitely classified as a flash drought, which began about October 10th. So we're like about in the, fifth month of it or so.
Yeah, when we talk about these probabilities, I think it's important to keep in mind how important the randomness of the weather is. So, for example, I don't know if these are the right numbers, but they're probably in the right ballpark. Climatologically, there would have been a 1% chance, say, of having conditions this dry in any given winter. And it's possible that because of the setup of La Nina and so forth, the odds of having a winter as dry as this in the southern plains increased to 3%. But we had to miss a lot of individual weather events for things to work out the way they did.
Yep. It's almost always the way it works. And it wasn't a very strong La Nina either, which is also a sort of a getting more into the technical details here, a little more of a telling thing in terms of using El Nino or La Nina strength to really come up with anything, to be honest with you. This is a second, one thing I was going to say earlier, and I thought, oh my God, no one wants to hear this, but this is a second year La Nina, which does have, this isn't statistical because there's not enough of these episodes, but there does seem to be a propensity for dryness, especially in the southern plains, during a second year of La Ninas. It's more rule of thumb than reality, if that makes any sense.
Okay, any last rounders out there?
Greg Schuler here with a comment directed for John specifically. Are there any parallels back into the 1950 to 57 drought? And keep in mind 1954 and Marcia Wyatt's 64-year stadium wave work. Done with the
yeah, we seem to have been in a dry period from frequent drought from 1996 to 2015, and that would line up with the drought of the 1950s. I mean, right now the main parallel is both of them were dry in the same areas, but of course 1950s drought, 51 to 56, was a region-wide drought affecting ultimately almost half the country, and individual years in those periods were dry in different areas. But because of the PDO, I don't think this should be necessarily seen as the beginning of a extended drought period like the 1950s drought was. Of course, the weather can work out differently, but I don't think the decade scale conditions are in place for that.
That's a wrap. I think, Victor, you've got your hour and 1 minute. So
okay. So thank everyone for participating. Please send John or me an email if any further questions, any requests, for areas to cover in the next presentation. And we'll do this again next month, since I don't think things will be appreciably better. And we'll get the information at that point in time. Doug or Elizabeth, anything you all want to add?
Not from my side. Thanks for participating. Thanks a lot.
Thank you folks for putting this on.
You're welcome.